you. Okay, how are we all doing? I think that, even though I've got a PhD in robotics, by the way, probably got 1 mark out of that quiz. So do not ask me to be in your team at all, right? Anyway, I'm presenting the Smurfs, Symbiotic Multi-Robot Fleets, not the blue cartoon characters. I started off my degree at Heriot-Watt University in Edinburgh. Sorry, I'm losing my voice at the minute. I recently joined the University of Glasgow 2 years ago, midway through my PhD, when my supervisor jumped ship as well. So I followed him along. I recently was on a 5-month project at Caltech. If anyone knows the Big Bang Theory, can't remember the guy's name. All of them, right? Perfect. Apparently they all go there. So yeah, Ivy League University madness. Couldn't believe I got it. I'm a newly finished PhD student. I'm not quite a doctor yet. I'm still waiting on the certificate. I'm saying to the guys here that I know that's a bit like putting up an umbrella inside. I don't want to jinx myself. I'm recently Rising Star, heading to Virginia in cyber physical systems, which is to do with robotics, and then also the Institute of Engineering and Technology, Rising Star last year at the end of the month. So moving on to the Smurfs. So managing expectations and delivering value to start with, right? A lot of my PhD is face a challenge, can you address it? So a couple of the key headlines that people may or may not have seen. Toyota pulls self-driving e-pallets from Paralympics following a crash. A moment where autonomy has failed. Basically, there was a human driving the Toyota e-pallet and it ran over one of the Paralympians, right? No major injuries, but enough to make the news. The slow collapse of Amazon's drone delivery team. I think they only roll it out in California, maybe because they've got the least amount of safety rules out there. But yeah, I've still not seen Amazon drone delivery team, and I think they started to trigger mass redundancies within AWS as well for that segment. US probing fatal Tesla crash that killed pedestrian. Now, there's been a couple other headlines since then, but I've actually got pulled stats from Tesla as well, because us researchers love to give a balanced view, where Tesla's figures, the likelihood of an accident is 152 years, which means I shouldn't technically have an accident when I'm in America if I'm in a self-driving car, when compared to the government stats. And that's coming from someone who's driven in LA, where it's hectic, 5 lanes. These guys don't have rules. It's madness, honestly. So, robotics and artificial intelligence. I'm going to start off with what people think robots look like. The Terminator, whatever his name is on the quiz, not sure. What they are actually like, what the robots I work with. Drones, the Husky robot. I've got a quick summary of Symbiotic Multi-Robot Fleets, the Smurfs. I'm going to go with the acronym from now on. Think about the Smurfs. We've got Clever Smurf, Papa Smurf, who's wise, Hefty Smurf, Harmony Smurf, who's creative, Painter Smurf, who's artistic. And what we're trying to do is, within robotics, no one has got a silver bullet solution to a robot that can do everything. A lot of the robots that I'm working with are aimed at offshore renewables or the nuclear sector. And what they're trying to do is get into different nooks and crannies. Bigger isn't often better, to do different inspections, with the ultimate goal of increasing safety and reducing costs to energy. I don't know if anyone's seen their heating and electricity bills. It's a nightmare. So this is the kind of influential steps going onwards. In terms of another segment of my research down the bottom left is like, how do you coordinate these different robots, where hopefully we'll have one human in the loop to coordinate these different robots via autonomous missions. You'll still have people in the field as well, because as I'm about to show you, robots aren't amazing yet. There's still decades to go, okay? So a couple of robots that I've worked with. We've got the Unitree Go 1, which is a legged quadruped from China. This is the robot that I worked with in LA. And basically, with this research, we were using a brain-computer interface, which is like a rugby scrum cap you put on your head. It's really bad. You think about this movement, so I'm not moving. I think about it, the robot turns right. You think about this movement, the robot turns left. Sitting in a seat, kicking my legs, the robot moves forward. So we managed to get that right 71% of the time. Woo! Okay, which compared to the start, incredible. However, that was a bit like torture because I need to sit still for, 15 minutes times 10. So 3 hours worth of testing. The second robot there, I'm just going to go back, sorry, I've jumped a bit. The blue robot that's going to start moving in a second, that is the Karma robot, which has got multiple radiation sensors on there. Oh, it doesn't work on the screen. So basically, with respect to that, at the minute people are sending humans in, you don't try and minimize humans in radioactive areas, of course, obvious reasons of cancer, etc. So we can send this robot in to do the monitoring, then update, is it safe for a human to go in? Simulations of said robot from Quiz, Spot, Boston Dynamics robot, and then also just a little bit of context in terms of offshore robotics. Looks glamorous, but it's actually not most of the time. We just need to look outside the window to see today's weather conditions. Never mind being on a boat like these guys. That should never happen, for sure. Where the safety is there, crazy. And of course, the fails. So within research, we're obviously working with loads of robots. My favorite video that has got absolutely no views on my TikTok, if anyone wants to go check it out, at Robot Myths. Guido, the fastest wheel changer of all times. I think he takes about 3 seconds. With the Husky robot I was working with, any estimates before it comes up on the screen? 3 minutes, double it, triple it. 9 minutes. 9 minutes it took. Two pairs of hands, and a lot of nightmare words probably came out there as well. Next up, the Spot robot. We utilised image processing to detect a box and to try and collect the box. And the robot still thinks it's got the box. So there's many steps to be taken. Finally, we've got a DJI Telodrone, another Chinese drone as well. We forgot to tell it to stop going up. It just keeps going. Right? Okay. And finally, lastly, we've got obviously cyber physical systems. This term cyber, this segment, the physical robot, wasted like GTA. Right? I don't know if there's definitely gamers in here. Send help, okay? So this is my @RobotMyths TikTok page. Love the outreach. Feel free to follow, like, subscribe, all that stuff. So what have you seen so far? Getting closer to the Smurfs now. We have seen individual robots with a human at the other side, programming it. When we look at an offshore facility or a nuclear facility, we still want people there doing jobs, people working alongside robots, but how can we actually coordinate these robots in an effective way? Within a lot of these facilities, such as Chevron, Shell, BP, Chevron set a 1-year non-intervention challenge. Now that means I should be able to deploy a robot for a year and never touch it, right? And as you've seen from my robot fails, we can't even do it on land, never mind offshore, right? So what we're kind of looking at moving forward is how can we minimize the amount of people there. Now you're probably wondering, why is Jose Mourinho on the screen right now? So Jose Mourinho, for anyone who doesn't know, incredible football manager. And when he was becoming a manager, he realized he couldn't communicate with all his players because they're all international players. They speak a wide range of languages. So he learned a load of languages. With respect to robotics, we've got tons of different languages for robots. Working from the top right, the Boston Dynamics Spot is actually a black box you cannot access, right? We can only use what's called their software development kit. So similar to like a graphic user interface with buttons, the controller that they provide, programming it is a no-go unless you put your own hardware on top of it, which is then even more costs. Oh, I've jumped a bit too, I've jumped the joke already. The next one, the wheeled robot, is a robotic operating software, which is something that is upcoming. Hopefully in the next decade, everyone's going to be using ROS because it kind of takes in all the different programming languages into a more easily adaptable and convertible way. We've got C++ down the bottom right, which is another programming language, hardware description languages, which are for the specific electronics themselves. And you can kind of see how it keeps going on. So the special one moves to the unlucky one, right? Whose job is it to figure out all these different languages and translate them all in a way, right? I don't know if you recognize that guy anyway. So the future. Symbiosis, right? So symbiosis is a concept that I've came up throughout my PhD. And basically what it looks at is mutualism, where two elements benefit each other. Commensalism, where one element benefits, and you can even get parasitic reactions across your robots, okay? The second element is these robots all communicating with each other in a way that they can actually speak to each other. Because at the moment, you've got a human needing to do the communication to say, my robot's stuck, it's fell on its back, it can't get up. Okay, can you actually go out and get it? Then there's another element as well where cars get their MOTs every year. We buy a robot, we deploy it as safe, but we don't think about, a motor's going to break in a year. So there's 3 people's salaries for one robot, which doesn't seem efficient to me. So in terms of current versus offshore wind farms, these are little like 3D models that I've created and stuff. But what we can see from current offshore wind farms, obviously, to reiterate the point again, this is perfect weather conditions. So some of the challenges we want to address are weather-dependent deployments. It's also expensive. Every time you need to send out a helicopter with people on board. You've also got long durations of inspection, and then also questions around safety, because we're not just operating above the sea. We're also sending people down to foundations for subsea cables, also for the foundations and things as well. And that's where you've got underwater currents that really come in and these like challenging environments that are extreme to operate in. So how do I see the next 20, 30 years in an offshore facility? And I see that as no silver bullet robotics, a wide range of robots all working together as a team, where you've got someone operating from land, chilling on their computer, working from home with their cup of tea, but they still have the ability to have a full operational oversight of their facility. And it's not just about robotics, it's about the sensors that are in your wind turbine, it's about the warning sensors that are in your substation. You're looking at this is where a cyber physical system really comes into play, where you can access your computer and visualize a complete digital replica of your offshore facility. So some of the knowledge gaps that I'm sort of addressing are resilience, where robots can overcome these difficult challenges, such as a robot falls over, can another robot help it? Such as the weather's really bad today, which robot should we actually send out to be able to still do an inspection? So, get into the Smurfs, what you guys have all been waiting for. And Mario Kart, because this is actually something that sort of came up a wee while ago, but just after my abstract. So just to reiterate, we've got lots of different Smurfs. They operate well as a team. However, the challenges are, if we take this Smurf standpoint in robotics, robots currently operate in silos individually, so there's no communication. Robots struggle to overcome challenging scenarios, such as maybe a wheeled robot coming up the stairs. Mario Kart. So, in Mario Kart, each car has a different capability. Who knows a Mario Kart character? Stuart, I know you do. Bowser, right? You've got Mario, you've got Luigi. All these different cars have different speed, acceleration, all this stuff. It's the same when it comes to robotics as well in our multi-robot fleet. So when I mention this cyber physical system, I'm going to display it as the Smurfs, and then we're going to display it as robotics, right? So you've got Papa Smurf, the wise one, okay? Which is me, the human in the loop, right? Not because I'm wise, but because I'm a human, okay? Next, you've got Clever Smurf, aka artificial intelligence, right? A bit overrated artificial intelligence, if you ask me, but maybe controversial. An automated co-pilot. If I've got lots of data coming to me, I can't make every decision because I just get overwhelmed. It's a term called cognitive overload. Basically, just imagine your brain exploding, right? Next up, you've got the Smurfs deployed in the field. So emphasizing a range of different capabilities, a wide range of abilities. Teamwork makes the dream work, okay? And that's where we've got hefty Smurf, flying Smurf, I think, and artistic Smurf. Now, back to our Bowser theory. I'm glad you said Bowser. It was almost like I paid you, right? Bowser, heavy Mario Kart. Nobody's crashing you off the road if you've picked Bowser on the Wii or whatever, right? Now let's take that with respect to the Husky robot we seen earlier. Husky's got an incredible battery life. It can have a wide range of sensors because it's such a big robot. It's a heavy weight. However, it can't climb stairs and it can't fly for obvious reasons. Next up, you've got the Spot robot, which has a little bit less of a battery life because it's got less of a size body to get a lithium battery on. It can take a little bit less sensors. It has a heavy weight. It can go over stairs this time, but it can't fly. As well, I've got these kind of like power-ups as well, which are like the sensors that you can put on the robots. Sorry, I missed that point. And then finally, we've got our the two robots that I've mentioned already can't fly. So this is where our DJI Telodrone comes in. Now this drone is only £100. You guys can buy it off Amazon, easy peasy, right? But don't underestimate, like, smaller is sometimes just as effective as a large robot. Because at the end of the day, if this was a substation, you still need to inspect that corner and get a good view of it. And if it's a human up a ladder, it could be quite dangerous. But if it's a robot down here, there's no way you're going to get the best view unless you're a drone. Okay, so my first demonstration was looking at this offshore substation scenario. So we basically created a house of horrors for robotics and deployed our robots and tested them against resilience, safety, and reliability. Within the Smurf approach, what you're kind of seeing on the left here is this scenario where it's finally working. We got it working with the gripping scenario, where the robot collects an analog battery for the Husky robot, right? So basically, on the bottom left, so actually before the camera on the UAV has just came up, it's done a quick inspection. It's a really basic robot, so we just had it fly up and down. The large robot that's moving now is called the Husky, and that's done an inspection at the aluminium sheet. It's turning back. But the thing about the Husky robot was we wanted to test the reliability. So we induced a fake failure on the robot to say, okay, your motors are a bit too hot, right? And there's a watchdog node there that should hopefully snap open and say, okay, your motors are hot, but continue the mission. It's not in a fault threshold, right? Next up, what we then done, as you've seen, the Spot's just dropped off the battery, is we then said to the Husky robot, and we said, your battery has actually failed. And the Husky has the ability to say, my battery's failed because my watchdog node has just figured it out. Is there a robot available to do some work for me, right? The Spot says I'm available, and the Spot goes and collects the battery. Now, the thought behind the Spot robot is look in the surrounding area, identify the battery. So keep in mind that it's quite an advanced area. There's loads of different lighting conditions, lots of different targets. It identifies the battery completely by itself, collects the battery, and takes it over to the Husky robot. Sorry, this is just getting to like a cool compilation bit whilst I kind of describe what was going on previously. Then, once the Spot's collected the battery, its next task is to identify the Husky robot. And that's where the Spot robot turns by itself, moves over to the Husky, and drops the battery down. Now, I'm not saying that a robot is going to be able to, in the next decade, be able to take itself apart and then put its battery into its body. But the capability is kind of proving these points in terms of Husky maybe needs a tool, maybe it needs a hammer, and it's not got a hammer. Maybe it needs a drill, and it needs something to be brought over to it. So that's where these kind of elements of symbiosis come into play. As another element that I've kind of emphasised with the Spot and its wheels, if a silly human who isn't as wise, right, gives a robot a mission, can that robot identify, okay, I can't actually do this mission, where's my mate for some help? And then this is kind of an overview, right? Remember when we looked at the Smurfs and the Smurf architecture? This is now the symbiotic architecture. So at the top left, you've got the human in the loop and his hard hat, chilling at home with his cup of tea. and he's accessing the digital twin, which is where you've got your computer and you're seeing everything, as much information as possible about your offshore facility, about the robotics that are completing the mission. Shifting across to the right, you've obviously got your robots in the field, and then going to the top, we've got asset integrity inspection, which was the purpose of the mission. So is there corrosion in your facility? Is there a gauge that's in the facility that's maybe too high and there's high pressure, so we need to fix that? And then lastly, down the bottom is this runtime reliability ontology, we called it, which is where if you've got a warning sign in your robot, you've got a watchdog node that can detect that, and it sends the information to the robot, but also sends the information to the human to say, I'm about to fail. We need to do something to fix me. So next up is my second demonstration, which was robotics for nuclear environments, right? So I don't know if anyone's ever heard of Cellfield, which is a large nuclear facility in Cumbria. I think it's one of the first nuclear facilities that was ever created in the UK. However, there's 100+ years jobs to decommission this thing, which is crazy because that's basically the nuclear facilities all take this defense in depth approach where any new technology needs to be tested 100% for obvious reasons to avoid Fukushima and things like this, because it's a bit there's challenges in the way that the world is, especially just now, to make sure everything is as safe as possible. So what we done was we looked at utilising our multi-robot fleet, different range of robots, for post-operational clean-out, which is where you need to inspect a nuclear facility every 3 to 6 months. This was a 5-day sprint, okay? And this was all engineers from the University of Manchester, Bristol, and Glasgow, who all went to Cumbria into an analogue nuclear facility where this facility gets treated as if it's nuclear. So kind of walking you through the demonstration here, what we planned to do was look at different steps to inform on how people can deploy robots in a nuclear facility. And step A is mapping it, because you don't know, has your facility changed? Is it that the roof has crashed in? Is there new materials in there? So one of the things that we do is we utilize this 3D map, which is created via LiDAR sensors, they're called, just lots of lasers getting shot about everywhere, and then presenting that information in a digital environment here. So technically you should have a computer design of your facility, and what we do is we overlay the LiDAR or the laser scan on top of there and say, right, has there been a change? The second step, you identify a change, you need to investigate it. We thought the best way was to get a live camera feed from a robot. Now, our cheap and nasty DJI Telodrone is coming into play again, right? Where, albeit you can't get any sensors on the robot, it's still got a 720p camera on it, which is pretty good for how small and compact a drone is. Sure, it's got a 7-minute battery life, right? It decreases, and trust me, the amount of times we've used it, it's not got a 7-minute battery life anymore. These things half, right? But as you can see at the top right there, we've got some sort of like nuclear radiation liquor, it's called, Diet Coke and salt is what it was. And we've been able to identify that, right? So one of the issues with that is that going to spread further across the nuclear facility? How can we contain it? Is it even radioactive? We don't know these things. So that's where we then send in our next robot, which is the Karma robot, if you guys remember from earlier. So the Karma robot has got that kind of horn antenna, that's for moisture detection. We've also got several radiation sensors on the back there, so as the robot backs in, the first thing it's saying is that actually wet, or is that, I don't know, like paint, or is it just a shadow, for example? The second step is then, is that actually radiation? The third step is, can we try and avoid driving over it if it's radiation? Because if we're going to spread that around the facility, then that's another danger. These graphs, don't worry about it too much. It's basically just how to detect moisture. So one of it's really wet, one of it's damp, one of it's completely dry within there. And then, of course, we need to, showcase that information in an actionable way to the human in the loop. So where you've got the barrel, once it comes up in a second, it kind of gets highlighted a little bit with a marker where you've got the blue light there. And then another thing about the Karma robot is in these facilities, no matter how large they are, you need to walk about as if you're detecting for mines in an array, right? Now, as you're walking in that array, I'm thirsty, I kind of get a bit bored. Robots don't get bored either. They can do dull, dirty, dangerous tasks, right? And they'll just keep doing them until their battery runs out. So the Karma robot can technically do this job more effective and more accurately. Finally, how does the Spot robot come into play? Well, the Karma robot's got the sensors kind of, if I take my pint here, and it's just holding it along, but it can't actually move the sensor up to high areas. And in the nuclear sector, they like to know, I can't remember what this is called now on the spot, but they want to know the amount of radiation at all of your vital points. So with the Spot robot, you take the sensor, and what we're doing is we're measuring the amount of radiation up and along this barrel. Now, of course, we don't use real radiation here. Okay, I am in proximity to a dangerous area, if so. But this is where these kind of elements of symbiosis come into play. Robots helping out each other, something that nobody's really clicked onto at the minute in the multi-robot fleet sector, hence the Smurfs. And guys, that's everything from me. So if you guys liked anything, we've got our Smart Systems Group YouTube page for more videos and things. I recommend checking out the multi-robot fleet robot myths page, which has got over 60,000 views in the last 2 years. So feel free to ramp them up. And that's all from me. Thank you so much, everyone.